Hey guys, welcome back to Chemistry with me, Miss Thomas. I am not showing myself today because it's quarantine and I look like I have been quarantining, so here we are. By the end of today's lesson, you will be able to convert between moles of reactant and moles of a product again, but today we're gonna add on a few more steps. So let's do a quick recap of what we did yesterday. Yesterday, we learned what a mole ratio is. It is just the ratio of moles of reactant to moles of product and vice versa. We also learned that we can use this mole ratio to convert between moles of a product and mole of a reactant. So we're going to do this quick example just to refresh everybody's memory, and then we'll move on to today's lesson. So our example is, given the following balanced chemical equation, how many moles of sodium iodide are needed to produce 7 moles of iodine? So it said that we have moles of iodine and we are trying to convert to moles again. So we're going to be using this mole ratio. So the first thing I like to do is set up my little chart so I know what I'm doing. Then, obviously, I need to write what I have. I have 7 moles of iodine, and I need moles of sodium iodide. So I put that here. Cool. How can we go from this mole to this mole? We use the ratio, right? So the ratio of NaI to I2, we go to the formula, and we look at the coefficient. So in front of NaI, we have a 2, and in front of I, we have nothing. So the ratio must be 2 to 1, which we just read from here. Now we're going to use this mole ratio to convert. So do you think that I'm going to put the mole ratio of iodine on the top or on the bottom if I need to get out this? I'm going to put it on the bottom so they can cancel. And then I'm going to put the 2 moles of sodium iodide on the top. So now I can cancel out these 2 units, and I'm left with mole NaI, which is what I need. So I'm just going to do 7 times 2, which gives me 14 moles NaI. And that's what you did yesterday. So this is what you've done all week, or over the past 2 weeks. But today we're going to combine these last 3. So you just did an example of moles to moles. Today we're going to be able to go from grams to moles or atoms to moles. We're just going to mix all of these up. You ready? You're ready. So let's go. So this is going to be the chart that we're going to use in every question. It's going to make our lives very easy because it just provides us the steps for converting from one to the other. So our first example, we are going to practice how to go from grams to grams. So let's read this. It says, find the number of grams of iodine that will be formed when 300 grams of bromine react. So I'm going from grams of bromine to grams of iodine. So let's check out our chart. We need to find our starting place. So I'm starting at grams, which is here, and I need to get all the way over to grams here. So in order for me to do that, I need to go from my start place to here to moles, which is going to be step 1. And then step 2 is going to be to use this mole ratio to get to our final step, which is this. Does that make sense? We're just going to follow this path. We're going to follow the path. So let's do it. Okay, so the first step of our path said that we need to convert from grams of bromide to moles of bromide. So how do I do that? I use the molar mass. You guys should be really familiar with this now. So I'm going to kind of speed through step 1. So the molar mass of bromide, we use the periodic table to find out. It is 80 grams per mole. We have 2 of them. 80 times 2 is 160, sorry. Then I'm going to set up my chart. We always start with what we have. So remember, we have 300 grams of bromide. We got that from the question. And we're going to use our molar mass to get out moles of bromide. This is what it says. We need moles of bromide. So will I put my 80 grams on the bottom or on the top in order to cancel out the units? I'm going to put it on the bottom, right? So I put my 80 grams on the bottom per mole on the top, and then I'll be able to cancel out these. There's grams and grams. I am just left with moles and moles. So I just need to pop this in my calculator. So I need to put 300 divided by 80 in my calculator, which gives me 3.75 moles of Br2. So let's record that up here. We're going to keep track of everything right here just to make life a little bit easier. So now that we got that, we can move on to step 2. So step 2 from our chart told us that we next need to convert from moles Br2 to moles I2, as it says here. So how can I convert from moles to moles? Let's look. So we just did step 1. We're here, mole to mole, use the mole ratio. So let's do that. So the ratio between Br2 and I2, we need to look at the coefficients up here. Br2 is here. It has no number in front, so there must just be one of them. The same is true for iodide. So the ratio is 1 to 1, which makes our life really easy. Because when I set it up with what I have 3.75 moles of Br2, which comes from here. And I need to get out moles of iodide. So I'm going to use this ratio, this 1 mole to 1 mole ratio, in order to cancel these out. That means I need to put 1 mole of Br2 on the bottom, and then the 1 mole of I2 on the top, which is coming from this ratio, so that I can cancel these two out. Mole Br is gone, and I'm just left with mole of iodine. Now 3.75 times 1 equals 3.75. So let's record that up there. Look guys, we're almost done. So now we have 3.75 moles of iodine. Our last step is to convert it into grams. So step 3. So here's my chart again. We are now here, and it says in order for me to go from moles to grams, I have to use the molar mass. So let's use our molar mass of iodine. If you look in your periodic table, you will see that iodine has a molar mass of 127 grams per mole, but since we have 2 of them, the overall molar mass is going to be 254. Next, I set up my chart by starting with what I have. I have 3.75 moles of I2, which came from here. And I need to get out grams of I2, because that's what the question asked us. Therefore, I'm going to use the molar mass to convert between my moles and my gram. So, am I going to put my 127 grams on the top or on the bottom if I need to get grams out? I'm going to put it on the top, right, which means I need to put my moles on the bottom. So moles on the bottom, grams on the top. This will allow me to cancel out my mole unit and leave me with just grams, which is exactly what I need. So now I just need to pop this into my calculator. I need to do 3.75 times 254. And when I do that, it gives me 952.5 grams. And that's our final answer. As simple as that. All you need to do is have your summary chart and follow the steps, and you will arrive at the correct answer every time without any complications. So I'm going to put this to the test by giving you a problem to do by yourself. On the Google form below, you're going to complete this question and put your answer there. So go ahead and pause the video, complete the question, and then come back. because we're going to do a different type of question. Okay, so you're back. So you just did grams to grams successfully, hopefully. Now we're going to combine grams and moles. So this time it asks us if we have, or how many moles of carbon dioxide would be produced if 2.4 grams of C2H4 were used. So let's look on our summary chart. It says we are going from 2.4 grams to moles. So I'm starting here at grams, and I need to get to moles of a different compound. So I have step 1 is to convert from grams to moles, and then step 2 would be from moles to moles. So let's do it. So step 1, grams to moles using molar mass. We're very comfortable with molar mass now, so I'm just going to pop it up there. The molar mass of C2H4 is 28 grams per mole. Now, I'm going to set it up, and I always start with what I have and what I want. So the question gave us 2.4 grams, and we are trying to get moles for our first step. So am I going to put 28 grams on the top or on the bottom if I need to get moles out? Right, I'm going to put it on the bottom. So let's do that. And I'm going to put my mole on the top. Now I just need to punch this in my calculator. So I'm going to do 2.4 divided by 28 in my calculator, which gives me 0.086 moles. So I put this up here in our summary, so just so we can keep track of where we are. Now, are we done? Nope, we still need moles of carbon dioxide. So let's check out step 2. So step 2 says that we're going from mole to mole using a mole ratio. Oops. So we're going to convert using the mole ratio, so let's figure that out. We have C2H4 to carbon dioxide. And I use my coefficients to figure out the ratio. So CH4 has nothing in front of it, which means there's just one of them, and CO2 has 2 in front of it, so it has a ratio of 1 to 2. Now, in order to convert, I'm going to set up my chart and start with what I have. I have this. I have 0.86 moles of C2H4, and I'm trying to get out my final answer of moles of carbon dioxide. So, if I need to get moles of carbon dioxide out, what am I going to put on the bottom here? Right, so I'm going to put my moles of C2H4, which is 1, which I got from the ratio, to 2 moles of carbon dioxide, which will allow me to cancel out my units and get my final answer. So let's cancel these out to make sure. Perfect, we have mole CO2, mole CO2. We're on the right track. So in my calculator, I'm going to do this number times 2. Which gives me 0.17 moles. And we are done. So guess what? You're going to do a question by yourself. Pause the video here and complete this question on the Google form below. Cool. So this is the last type of question that we're going to do. This time we're going to incorporate molecules. So our question reads, if 90 grams of water were used in this reaction, how many molecules of hydrogen are there? So let's look at our summary chart first. So we're starting with grams, and we need to get to molecules of a different compound of hydrogen. So I'm going to go from grams to moles, use a molar mass, then moles to moles, use the mole ratio, and then moles to particles or moles to molecules, in which we would use Avogadro's number. So let's give this a shot. So I put a summary chart here just to help us keep track of it all. And we're going to start off with step 1. So step 1 is to convert from grams of water to moles of water by using molar mass. We know how to do this already, so I'm just going to give you the molar mass of water is 18 grams per mole. And then I need to set it up starting with what I have. I have 90 grams of water. That's what the question said. And I need moles of water. So I'm going to put my 18 grams of water on the bottom and the moles of water on the top. Let's make sure that these cancel. Yes, that cancels, which leaves me with these two. Perfect. And in my calculator, I'm going to put in 90 divided by 18, which gives me 5 moles of water. Our first step's done, guys. We're almost there. Step 2. We need to go from moles to moles. So let's look at our summary chart. It says to use the mole ratio here. So let's use it. So I need the ratio between water and hydrogen. So let's look at our coefficients here. I see a 2 in front of the water and I see a 1 in front of the hydrogen, which gives me a ratio of 2 to 1. Now, I set up my chart and I start with what we have. We have 5 moles. From step 1, we need moles of hydrogen out. So I just need to make sure that I cancel out my units here. So I have 2 moles of water. I'm going to put that on the bottom. And then I have 1 mole of hydrogen, which was given to me from this ratio. Let's make sure that I'm right by canceling out. So I see a mole of water here, a mole of water here, and then a mole of hydrogen, a mole of hydrogen. So we're doing well. Next step, in my calculator, I do 5 divided by 2, which gives me 2.5. Put it up here in our summary. Now we only have one step left. Step 3. So I need to go from moles to molecules. But how? Let's look. It says to go from moles to molecules, we, smooth this, use Avogadro's number. So, what is Avogadro's number? Does anybody remember? It is 6.02 times 10 to the 23 molecules per mole. So, here is my chart. I'm going to start with what I have. I have 2.5 moles of hydrogen from step 2. And I need molecules of hydrogen. So, am I going to put my 6 times 10 to the 23 molecules on the top or on the bottom? I'm going to put it on the top, right? So I can cancel them out. So let's make sure that we are correct by scratching out some units here. I have mole H2 and mole H2. Good, which leaves you with molecules of H2, which is exactly what we need. So in my calculator, I'm going to do 2.5 times this number, which gives me 1.505 times 10 to the power of 24. This 24 should be on the top. Let's fix that really quick. And you did it. That's our final answer. So you're going to do this question by yourself. This is the last question you're doing by yourself on the Google form below. So look how much you have done. You've done all of these things. And in particular, today, you combine the last 3 points, these moles, grams, and atoms. So great job. Don't forget to do your exit ticket, which is in the next section of this worksheet. And I will see you guys later. Also, feel free to reach out to any of your chemistry teachers or myself if you need help with anything that was talked about in this video.